Hey y'all. So today's lesson is conditional probability. Conditional probability is where a certain prerequisite condition, that just means has to come first, so it's already been met. Whenever you have conditional probability, there are like one formula, but it can just be reversed for two events. So the probability of event A given event B. When you have this line in the middle, that means given. So the probability of A given that B has already happened is equal to the probability of A and B, the intersection, divided by the probability of B. Whatever the given is has to go on bottom. If the problem is the probability of B given A, meaning B, the probability of B happening given that A happened, is the probability of the intersection A and B divided by the probability of A. So you notice whatever is the given is going to be the probability of the given is going to be on the bottom, the denominator. Now occasionally you might need to use the same formula, just an alternate look. If we were to multiply this by probability of B, it would cancel out, and then we would multiply this side by probability of B. And we could do the same thing here. We could multiply both sides by the probability of A. So sometimes you might see it written like this. The probability of A given B times the probability of B is equal to the intersection. The probability of B given A times the probability of A. So see, just this denominator is moved over here. And that's equal to the intersection, the probability of the intersection. So I'm going to show you how to find conditional probability. Alright, when rolling two dice, find the probability of rolling at least 1 3, given that the sum is 7. So I was going to make a table, but I did not make the entire table because I knew, given that the sum was 7, we needed to focus on the sum of two dice being 7. So I showed the outcomes 1 through 6, 1 through 6, and I know that I wanted at least 1 3. Given that the sum was 7, so I have to focus on these 7s. To find the probability of at least 1 3, given that the sum is 7, then we need to find the probability of the intersection, a 3 and a sum of 7, divided by the probability of just the given part, the sum of 7. So let me show you what I'm talking about. The probability of 3 and a sum of 7. So you can see that we have 6 7s, but the only time where there's at least 1 3 is right here and right here. So you can see there are 2 out of 36, because remember there's 36 different outcomes. That's the intersection, 3 and a sum of 7. There's 2 of them. Divided by the probability of a sum of 7. So you can see we have 6 sums of 7 out of 36 outcomes. So we have a fraction divided by another fraction. You can type that into your calculator, but I'm just going to show you a trick. When you were in, 5th or 6th grade and you learned how to divide fractions, you probably learned copy, switch, flip, copy, dot, flip, keep, change, change, or something like that. So 2 over 36 divided by 6 over 6 means we copy, we switch division to multiplication, and then we flip the second part. The 36 and 36 are going to divide out. They're going to cancel. And then we're left with 2 over 6. So the probability of at least 1 3, given that the sum of 7, is 2 out of 6. What that is saying is, given that the sum is 7, we've already said that the sum has to be 7. That's already happened. So if you have a sum of 7, well, 2 of them are going to have at least a 3. Because it's 3 and 4 and 4 and 3. 2 of them are going to have at least a 3. So 2 out of 6, which is 1/3. So that is an example of conditional probability. I'm going to show you more examples. Example 2. When playing a game, the winner is determined by drawing 2 cards of the same suit. What's the probability of drawing a club second given clubs was drawn first? So again, we have this word given. The probability of a club given that there was already a club drawn. The probability of a club and a club. It doesn't say in the problem, but we can know that this is without replacement because they're going to be drawing two cards, 1, 2, and they're not going to put it back. So the probability of a club and a club, when you see and, you know that means intersection. So the probability of a club is 13 out of 52, and the probability of another club would be 12 out of 51, because remember we didn't replace it. Just the probability of a club is 13 out of 52. And then to solve this, I already have this. To solve this, we would multiply and then divide. But if you see 13 out of 52 and 13 out of 52 are going to divide out, and we're left with 12 over 51. But you can always type this in your calculator and then get a decimal percent. This would reduce to 4 over 17. And then 4 out of 17 is approximately 23.5%. So we have about a almost 24% chance of winning this game, 4 out of 17, of picking a club given that you already picked another club. So if you pick the first club, then you have about a 24% chance of picking another club and winning the game. All right. In Mr. Klein's homeroom, 70 students, this is supposed to be 70%. 70% of students have brown hair, 25% have brown eyes, and 5% have both. A student gets checked out. Find the probability of brown eyes given brown hair. So the probability, the conditional probability. So whenever you have brown eyes given brown hair, we want to find the probability of brown eyes and brown hair divided by the probability of just the given part, just the brown hair. So in the problem, we know that there was 5% that have both. So our top, the probability is going to be 0.05 or 5%. We already know that was given to us in the problem. The probability of just having the brown hair was 70%, so 0.7. 0.05 divided by 0.7 is 0.071 about. So about 7.1% are going to have brown eyes given that they had brown hair. So what this means is, let's say a student randomly is called to be checked out, and the person called already had to have brown hair. Then there's a 7.1% chance that if they had brown hair, then they also have brown eyes. Oh, number 4. A bag contains 6 blue marbles and 2 brown marbles. 1 marble is chosen, then discarded, and a second chosen. Find the probability of brown given blue. Brown given blue. So we need to find the probability of brown and blue divided by the probability of blue. Remember, the given is what goes in your denominator. To find the probability of brown and blue, we need to find the probability of brown is 2 out of 6 plus 2 is 8. And then the probability of blue, now remember it's discarded, so there are 6 blue, but now there's only 7 left because it's discarded. Divided by the probability of just blue, so there are 6 out of 8. Now again, you can type all of this into your calculator, but you maybe can see that we can do some canceling. We have 8s and we have 6s. So if you see that we can do some canceling in the numerator and the denominator, then we're left with 2 over 7. And if you want to write that as a percent, then that would be about 28.6%. So the probability of choosing a brown, given that you've already chosen a blue, is about 28.6%. Okay, example 5. We have a chart. So in this chart, we are comparing 9th and 10th graders, 11th and 12th graders, and their mode of transportation to and from school. We have bus, walkers, cars, and other. And you can see the green is all the data and the red are the totals. And so the total is 500 students, 9th and 10th graders, 11th and 12th graders. We're going to use this information to find some probability. So the first one says, what's the probability that they're going to be a walker? So the probability of a walk, someone who walks, is 88 total walkers out of 500 total students. And so if you were to do 88 out of 500, you could reduce that to 22 out of 125. And then that as a percentage would be 17.6%. So just a simple probability. What is the probability that a student is a walker? What's the probability that a student would be in 9th or 10th grade? So we have 9th or 10th right here. And that is 210 out of 500. So 210 out of 500 is going to be 21 out of 50. And then 21 out of 50 is going to be a little less than half, so 42%. What's the probability that the student is a bus or an 11th and 12th grader? So this or, you have to decide if it's mutually exclusive or mutually inclusive. And could a student be a bus rider and an 11th and 12th grader? Yes. So these are inclusive events. So the bus riders are 147 out of 500. The 11th and 12th graders are 290 out of 500. Then you have to minus the overlap. How many 11th and 12th graders are also bus riders? Right there. So we need to subtract out the 41 because we don't want to count those twice. 147 plus 290 minus 41 is 396 out of 500. We want to reduce, and we get 99 out of 125. Those were all just basic probability. Now let's get into the conditional probability. The conditional probability says, what's the probability of randomly picking an 11th and 12th grader given that they are a car rider? So the given information is the car rider. First we need to find the probability of both. Divided by the probability of the car rider. So the probability of both an 11th and 12th grader and a car rider. So 11 and 12 and car rider is right here. So 187 out of 500. And then the probability of just a car rider is 254 out of 500. And then I told you before, just a little trick, if you have, when you copy, switch, and flip, you would be able to cancel these out. And then you would get 187 over 254. And then if you wanted to, I don't think it can be reduced, so about 73.6%. And it's pretty high because if you look, most of the car riders or most of the car drivers are 11th and 12th graders. So if you're given that it's one of the cars, it has a very, very high probability that it's going to be an 11th and 12th grader. The probability that you would get a walker given that they are 9th and 10th grader. So the probability of both divided by the probability of 9th or 10th. The probability of both, so we need 9th and 10th grade walkers, so 30 out of 500 divided by just the probability of 9th and 10th graders. So there are 210 9th and 10th graders. We can cancel out the 500, so we get 30 over 210, which can be reduced to 1/7. And then 1/7 as a percent is about 14.3%. So that is the conditional probability. Okay. Number 6, a survey asked teens which type of music they listen to. Out of 200, 75 chose pop, 45 chose country, and 22 chose both. Use a Venn diagram to find the probability of pop given country. So I already put that 22 were both. So if 22 were both, then there were 75 that chose pop. So 75 minus that 22 is 53. So 53 picked country. And then 53 picked pop, and 23 picked only country. 22 picked both. Now we know that there are 200. So 200 minus all of these means there are 122 students that must have picked another type of music, not included in pop and country. To solve the probability given pop, probability of pop given country means we need the probability of both divided by the probability of country. The probability of both is 22 out of 200, and the probability of just country is 45 out of 200. The 200s we see can cancel, and we get 22 out of 45. And then to change that into a percent is going to be about 48.9%. So right below 50. And that should make sense because about half of the country, people who picked country also said they liked pop, about half. So if you pick somebody who likes country, given they like country, then about half of them also are going to prefer to listen to pop. All right, we'll practice more conditional probability tomorrow.